Our topic for today will be on linear hashing. Linear hashing is a form of dynamic hashing scheme. There are other forms of dynamic hashing scheme as well as some that we might already be familiar with, such as extendable hashing. So how does linear hashing differ from other hashing schemes? Well, firstly, linear hashing does not require directories. It is capable of handling long overflow chains and is more flexible with respect to the timing of bucket splits. And lastly, it allows you to grow one bucket at a time. Here are some terminologies that are used in linear hashing. H0, H1, and H2 indicates the hash function at level 0, 1, and 2 respectively, and there can be as many levels as you require to hold your keys. N is the number of initial buckets, D0 is the number of bits required to represent N, and level is the number that keeps track how many split cycles that already been completed. And next is the pointer to the bucket next in line to be split. For now, we'll just introduce you these terminologies and they'll become more clear once we show you an example. Here are some math properties that will help us handle insert and search functions in the implementation. We usually pick our initial number of buckets to be a number that is base 2. For example, if we pick our initial number of buckets to be 4, then our D0 will be 2. This tells us that at level 0, we only need to look at the last 2 bits of the search key to locate our entry. For the ith level, di is given by d0 plus 1. So for level 2, we will need to look for the last 4 digits of the search key to locate our entry. The hash function for our entry at given level is given by the last formula, h key mod 2 to the power I times n. As mentioned on our first slide, linear hashing is flexible with respect to the timing of the bucket splits. It allows us to choose from 2 splitting criterions, either by load factor or by overflow. Load factor is calculated by dividing the number of entries over the number of buckets multiplied by the capacity of the buckets. You can set the split trigger to any load factor value you want, giving you a greater control in the space utilization of the hashing table. Another common split criterion is by overflow. This is very simple to understand. Once we detect an overflow, after insertion, we'll trigger the split. Now we will walk through our insertion example to get a better understanding how linear hashing works. For this example, a linear hashing table with the following setup. The number of initial bucket is 4. The current level is 0, and next is pointing to the first bucket. We would now like to insert 37. Since we are at level 0, we run h37 to get its hashing key. And at level 0, di is d0, which is just 2. That means we only need to look at the last 2 digits of the hash key to locate the right bucket, which is just 0, 1. Similarly, we would now like to insert 47. And we work out it needs to go to bucket 1, 1. Since 1, 1 is full, so we now need to create an overflow bucket and insert 47. And since our hash table is set to split on overflow, this now triggers a split. We'll now demonstrate how splitting is done. Notice we do the split on the bucket where next is pointing to, not necessarily the bucket where the overflow has happened. So we split the first bucket and increment next pointer to the next bucket in cycle. The next step that we need to do is to relocate each entry in the split bucket by recalculating its H1 key, and we now need to look at the last 3 bits to locate its bucket. Similarly, we insert 29. This will again trigger the split, so we need to relocate all the entries in the bucket and increment next to the next bucket. More example insert that trigger splits. We now want to insert 66, 34, and 50. When we try to increment the next, we have noticed that it went back to 0. This is because we have now completed a cycle, and every initial bucket has been split once. We will now need to update n to 8 and increment level to level 1. Notice the number of current bucket is always double the number of bucket on the previous level. And we need to relocate the entries in the buckets. Next, let's look at how we do a search with linear hashing. For example, if we want to look for 44, firstly, we need to calculate the H0 of 44 and check if it's in the range of the pointer x and n. If it's in the range, this means that the bucket it is in hasn't been split yet. So we just need to look for that bucket. If this is not in the range of between x and n, this means that the bucket has already been split. We might need to look at the bucket in the next level. So for our case, the H0 of 44 is the 0, 0, which is binary for 0, which is not in the range between 2 and 4. So we need to look at the H1 level. So the H1 of 44 is 100. We simply need to look up 100 in the H1 column to locate the right buckets to find 44. But that's it for linear hashing. Thank you for watching.